Hi everyone, welcome to today's lesson, which is harder pH calculations. So there's no specific syllabus outcome for these, but it's based on the last syllabus outcome about calculating pH, pOH, hydroxide ion concentration, and hydrogen ion concentration in different solutions. Now, a large amount of HSC questions actually involve calculating pH of a solution after a partial neutralization reaction has occurred. Basically, for all of these questions, we need to first calculate the moles of each reagent, find out what's in excess, and then the excess allows us to calculate pH or pOH, whichever one we're asked for. Okay, so we're going to go straight into some examples because the best way to do these is by doing. So example 1, calculate the pH of a solution produced when 100 ml of 0.1 molar HCl is reacted with 100 ml of 0.08 molar potassium hydroxide. So this is a nice basic one, but we'll go through it step by step so you know exactly what we're doing. So we first look at what information can we get from the question. So we look for numbers, compounds, units, and meaningful phrases, things like in excess, which won't be in this question, but other meaningful phrases we might come across. So let's have a look at the question. So we want to calculate the pH of the solution produced when 100 ml, so there's a number, of 0.1 molar HCl is reacted with 100 ml of 0.08 molar potassium hydroxide. So we've got this. We've got the volume of HCl equals 100 ml. Our concentration of HCl is 0.1 molar. The volume of potassium hydroxide is 100 ml, and the concentration of potassium hydroxide is 0.08 moles per liter. Now, what are we required to find? Remember, it usually tells us things like what is, find the, calculate, or evaluate. So this one says calculate the pH of the solution produced when that's all reacted together. So that's our end goal. Our end goal is pH. Now, how do we get from what we've been given to what we need to find? So this is where a flowchart will come in handy. Okay, so we've got we want to get pH. We get H plus from hydroxide ion concentration, or we get it from pOH and hydroxide ion concentration. So pH is from hydrogen ion concentration. Both of those can come from the excess chemical, and it depends on what the excess chemical is. Is the excess chemical an acid, or is it a base? Okay, is it going to give us H plus or OH minus? The concentration of the excess comes from the moles of excess, which comes from the moles of reagent that react. Now, to get the moles of reagent, we need either the mass of the reagent, the concentration, or the volume. Okay. So, following our flowchart, step 1 was calculate the number of moles of each reagent. So, we had concentration and volume of hydrochloric acid, so we can calculate the number of moles there, which gives us 0.01 moles. Same with potassium hydroxide, we have concentration and we have volume. So 0.08 times 0.1 gives us 0.008. Now that we know the number of moles of each, we have to find out which one's in excess. And to do that, we need to do our limiting reagent style question by first writing a balanced equation. So we know we have HCl and potassium hydroxide. So we follow acid plus base gives us salt plus water. So it's one of our general reactions. So HCl plus KOH gives us KCl and water. Now, is that balanced? Yes, there's a hydrogen, 2 hydrogens on both sides. There's 1 chlorine on both sides, 1 potassium, 1 oxygen. So that's all balanced. We don't need to do anything to that. So we can see that it's 1 to 1. Okay, so basically for every mole of HCl that reacts, 1 mole of potassium hydroxide will react. Okay. So our excess reagent is the one that doesn't completely react. Now we can tell this by the number of moles that are there, and our stoichiometric ratios and our stoichiometric units. So if we think about it logically, for hydrochloric acid to completely react, we require 0.01 moles of potassium hydroxide. But we don't have that much. We only have 0.008 moles. Conversely, for potassium hydroxide to react completely, we only require 0.008 moles of hydrochloric acid, which we have. Okay, so we can tell just from that our potassium hydroxide is going to be our limiting reagent. Okay, and our HCl is going to be in excess. Now, we can then calculate the excess using a modified ice table. So instead of initial change equilibrium, we're just going to do initial change and end. Okay, so let's just visually have a look at exactly how much of the HCl is going to be left over. So let's have a look. Initially, we have 0.01 moles of HCl, 0.008 moles of potassium hydroxide. Both of them are going to go down by the same amount. Okay, so when they react, they're going to go down and they're going to form that potassium chloride and the water. If we choose to take them down by 0.01, so the amount that the HCl has gone down by, then our potassium hydroxide also has to go down by 0.01. But then this gives us a negative amount at the end. And well, we can't have negative molecules, okay? So we have to make sure it's a positive. If we take them both down by 0.008 on the other hand, then we're going to be left with 0.002 of hydrochloric acid and no potassium hydroxide. So we know that that's the right one to use. It also tells us exactly how much is left at the end. So we're going to be left with an excess of 0.002 moles of HCl. Okay, so that's our N excess. Now, we follow our flowchart. We've got the number of moles of excess. What do we need? Well, we need concentration. Now, the key thing with concentration is that we need to take into account that we've mixed two solutions. And because we've mixed two solutions, the final volume is going to be the combined volume of those two solutions. So we had 100 mils and 100 mils. So it's actually going to, our volume total is going to be 0.1 plus 0.1 liters. And so it's going to give us a HCl concentration of 0.01 moles per liter. Okay. Now, we've got our number of moles, our concentration of our HCl. Now let's determine the concentration of hydrogen ions or hydroxide ions. So HCl, it's going to ionize into H plus and Cl minus, so we know immediately we're going to get hydrogen ion concentration, which will give us pH, nice and easy. Molar ratio is 1 to 1, so our concentration of HCl is equal to our concentration of hydrogen ions, which is 0.01 moles per liter. Now pH is negative log 10 of our hydrogen ion concentration, which was 0.01, so our pH is going to be 2. Okay. So hopefully you guys have understood that. If not, go back through that process, try and understand what we're doing at each step. As for everyone else, let's go on to another example. So what is the pH of a solution made from adding 4 grams of solid sodium hydroxide to 200 mils of a 0.1 molar HCl solution? Well, what information can we get from the question? Let's have a look. So remember, we're looking for numbers, compounds, units, meaningful phrases. So what is the pH of a solution made from adding 0.4 grams of solid sodium hydroxide to 200 mils of a 0.1 molar HCl solution? Well, we've been given a mass of sodium hydroxide, we've been given a volume of HCl, concentration of HCl. So what are we asked to find? Well, it's pH, so we weren't asked to find pOH this time. We were just asked to find pH. Now, how can we get from what we've been given to what we need to find? So this is our flow chart again. So we're trying to find pH. Okay, so we need to find that from either hydrogen ion concentration or indirectly through pOH and hydroxide ion concentration. And it all comes from the excess chemical. So therefore we need to calculate the number of moles of excess, and to do that we need the number of moles of reagent. So let's go number of moles of reagent first. So moles of sodium hydroxide, we have 0.4 grams over the molar mass, which is 39.998, which gives us 0.01 moles. That is rounded. Pretty sure it gives you like 0.010001 or something like that. Something slightly more than 0.01, but we'll round it to that for now. Number of moles of HCl. We don't have a mass of HCl, but we have a concentration of volume. Okay, so we multiply those together, which gives us 0.02 moles. Now, we have number of moles of NaOH is 0.01, number of moles of HCl is 0.02. So we need to find out how they react. Write a balanced equation. We know hydrochloric acid is an acid. Sodium hydroxide is a base, so when they mix we get a salt plus water. So it's going to give us sodium chloride and water. Okay, just double check that's all balanced. I'm pretty sure it is. Looks okay to me. So from that we need to determine the molar ratio. 1 to 1, nice and easy. So for every mole of HCl that takes part in the reaction, 1 mole of sodium hydroxide will take part. So again, for sodium hydroxide to completely react, we require 0.01 moles of HCl, which we have, because we have 0.02, so we've got enough. Thinking of it conversely, if we wanted to try and react all of our hydrochloric acid, we would require 0.02 moles of sodium hydroxide, which we don't have. Okay, so we only have that 0.01. So that's going to be our sodium hydroxide is going to be our limiting reagent. Just double check that. We can use our modified ice table. Okay, so they're both going down by the same because they're 1 to 1. If we try to take them down by 0.02, it's going to give us a negative concentration, which we can't have. So we're going to try reacting all of the sodium hydroxide instead. And remember, the change has to be equal because it's 1 to 1. And so we're left with 0 sodium hydroxide and 0.01 HCl. Okay. If we've got that many moles of excess, we need to calculate our concentration, which is 0.01 over 0.2, which is 0.05 moles per liter. So we need to determine the concentration of hydrogen or hydroxide ions. Well, we've got HCl again, so it's going to be hydrogen ion concentration. It's 1 to 1, so that means that our hydrogen ion concentration is equal to the HCl concentration, which is 0.05 moles per liter. So now we just have to plug that value into our pH equation. So pH is negative log 10 H plus, which gives us 1.3. Okay, so please have a go at the questions in the booklet. Please keep following that procedure. So find the number of moles, find which one's in excess, calculate the number of excess moles, calculate the concentration of the excess, and then pH or indirectly through pOH. Okay, so that's all for today. Thank you.